itself, and we've graphed them with the graphing calculator. Hit graph. We see that they intersect 2 times. Second trace, we want to find the intersection, so that's option 5. And then it asks for the first curve. Just make sure it's on the blue one. Press enter. Second curve, make sure it's on the red one. And then it asks us to guess. So what we want to do is move it closest to the one we want it to find first. I'm going to go to the left one first. I'm going to press the left arrow key till it gets close to where I think they're crossing. Negative 1.95 and negative 0.048. That's close to what I think it should be. I hit enter, and there it finds that intersection closest to my guess. Negative 2, 0. Didn't we find that one algebraically? When we worked it out, we got the intersection negative 2, 0. Okay, so that gets me one of my solutions. Let's find the other one. So we hit second trace. We go to 5 for intersect. It asks us for first curve. It's the blue one. Notice it'll say Y1 up here, and then Y2. And then it asks us to guess. So I'm going to move over here closest to the one that I need now, which is a little too far. It's close right there. Enter 1, negative 3. That same ordered pair that I had found algebraically, I find with my intersection tool on my calculator. Okay. The intersection tool on the calculator is really handy to find those intersections. If you can get the equation in the right form to be able to graph it. That's what makes it somewhat difficult sometimes, depending on the type of equation you have. All right. So let's look at another one that's maybe a more intense equation. So here's our equations. X squared plus y squared equals 4. And then 2x squared minus y squared is equal to 8. Now, algebraically, do we see how this one could eliminate just like the first one we did? When we got a positive y squared, and on the second equation we got a negative y squared, that they would cancel each other out. This one actually works out a little easier starting out, because when I add those two equations together, these are like terms. So 1x squared plus 2x squared is 3x squared equals 12, right? And the y squareds are gone, which is a fairly simple equation to solve. Divide by 3. There's x squared is equal to 4. And because it's just x squared equals a number, how can I solve that? Can I take the square root of both sides? What's the square root of 4? 2. So we get 2 answers there. We get x equals 2 and x equals negative 2. I need to find the y values that go with each of those. So pick one of the equations to plug those back into. I'm gonna pick the first one because it doesn't have, the negative sign in front of the y squared and all that stuff, so it just looks easier. Not that it really is, it just looks that way. So if I plug that into x squared plus y squared is equal to 4, so that's going to give me 2 squared plus y squared is equal to 4. What's 2 squared? 4. And that's equal to 4. So if I subtract 4, y squared is equal to 0. If I take the square root of both sides, what's the square root of 0? 0. I get an ordered pair 2, 0. If I do the same thing for negative 2, so that'd be 4 plus y squared equal to 4. Subtract 4, and there's y squared equals 0. Again, y is equal to 0. So I have ordered pair -2, 0. Now, I want to look at the graph to see how that looks. So I've got 2 ordered pairs that I found algebraically that are solutions to this. So when I graph these, how many places should it cross? 2. I think it should cross 2. If I don't do it algebraically, I don't know that. And that's okay if I don't know that. You got to work on getting the graph right. So we've got these 2 equations. How do I get y by itself for the first one? Subtract x squared, good. And that's y squared is equal to -x squared plus 4. Is y by itself? No, it's y squared. How do I get rid of the squared? Take the square root. And if I take the square root, I've got to put what in front of it? Plus or minus. Okay? So here, that's going to give me y is equal to the positive square root of -x squared plus 4. And y is equal to the negative square root of -x squared plus 4. In order to graph this one equation, I've really got to graph these 2 equations to get that. Because my calculator doesn't have a plus minus button on it. So I got to do the positive side and then the negative side. That's the reason I've got to do 2 of them. So I'm going to graph both of these when I go to graph. I'm going to graph this one and this one. It's going to together make the one graph for that original problem. And it takes 2 to make 1. Okay. All right. So look at the other equation. 2x squared minus y squared equals 8. Not much different in this one. Getting y by itself, what do? Yeah, subtract that 2x squared from both sides. So that's going to be -y squared is equal to -2x squared plus 8. What now? Can't do that yet. Or divide by -1, same thing. I'm going to divide. So that'd be 2x squared minus 8. And then I can do that square root. So I get y is equal to the positive square root of 2x squared minus 8. And y is equal to the negative square root of 2x squared minus 8. So I've got 4 equations that I've got to graph and see where, get. Remember, 1 and 2 go together, and 3 and 4 go together. They're technically one part of the graph, but it takes graphing both of them separately to get our calculator to handle it. So y equals, graph 1 is, what was it? Square root of -x squared plus 4. So square root of -x squared plus 4. And then the second one is the negative square root of -x squared plus 4. I'll show you that graph. Makes a circle. That's what that makes. There's in that movie, Now Pronouncing Chuck and Larry. Every time I say circle, since I've seen that movie, there's a scene where Rob Schneider is the Asian Canadian person, and he's saying, "A circle is a line that has no end." And I went to a wedding yesterday. Almost busted out laughing when they were talking about the ring as a circle. I was like, "Oh, I would never be able to officiate weddings because of that." So, but anyway, first 2 equations make one circle. Okay. The resolution gets too tight right here is the reason it doesn't meet up there, but it's there. Imagine they meet up. All right, so it makes a nice circle. If you don't have, I've got mine set to zoom square. If you've got it on zoom 6, yours kind of looks footballish, and that's okay. Doesn't really matter. Okay, so if yours looks like that, you're good. You're not seeing a circle at all. Let's look and see what's going on. zoomed out so far. That's what it was. All right. Anybody else having trouble? All right, so let's graph the other two that we found so we can see where they cross. All right, so y equals, and then we're going to zoom to 3. Equation 3 is the square root of 2x squared minus 8. 2x squared minus 8. And equation 4 is negative square root of that. 2x squared minus 8. Again, resolution's getting kind of tight right there, and it's hard for it to get that. That's a pretty sharp curve there. It's hard for it to draw it. But we see this coming in right here, and this coming in right here. What's happening is what this shape is called is a hyperbola, not a hyperbole like you would use in English, but a hyperbola, and it makes that shape. And what's happening is it's intersecting right there, right on the x-axis. We found that algebraically. If we want to find this graphically, we would hit second trace and then intersect first curve, second curve. We want to make sure it gets to, if we pick Y3, that's the black one for me on the color one, but it's Y3 is the top part. I hit enter there, enter. All right, kid, come on. Allow me to do it here. Not doing anything. All right, graph again. Okay, there's my graph. Second trace, intersect. First curve, the blue one. Second curve, 3. All right, it's still walking up here. Come on. First curve. Second curve. Now then. It's not hitting. Why is that? I know why. -2 doesn't work. Or +2 doesn't work in the square root part of that. 2 squared is 4. That square root is 0. That does work there. Be 0. That should be giving us that 0 out of that. -2, 0 is where they're crossing. Why I can't get it calculator to give me that. First curve on the blue, go to -2. That's somewhere close to -2. Second curve. Three. My x value close to -2. Bad guess. Awesome. Is that what you're set to? I don't think I've ever had that one before. I'll do that. I just picked awesome questions here. What happens if you zoom in there? Zoom in. Not zoom out. Zoom 2. Zoom to it's right there is where it's happening. So we can see by zooming in where they're brushing up against one another. What's really happening here, I think the reason we're getting an error is because this is a calculus thing. But you might have seen it in geometry. You know what a tangent line is in geometry? I remember hearing that word in high school geometry. Tangent means it touches it, comes up right to the edge of it, and touches it in one spot, and then goes away from it. That's what a tangent. And so really what's happening is this circle and that hyperbola are tangent to one another, and they're not crossing, like going through each other. They're just coming up and they're like bumping up against each other like that at that point. That's why we're getting an error there out of that. I just happened to pick good problems for that today as I was mixing that up. So good job, Mr. Hibbs. Way to go. Let's look at one that I know will work because it's not one of them's absolute value, so it works out great. Let's see, x squared plus y squared, 16. Absolute value of x plus y equals 4. All right. Now, we could do this algebraically. It'd be pretty ugly, though, because we don't have anything that's going to cancel out and eliminate, right? Because we don't have a positive y and a negative y, or even a positive or a negative x. And we've got that x locked up in absolute value there. It really can cause some problems, which, may not be really good for us. Okay, so what if we just tried to do this one graphically and got y by itself? The second one's really easy to get y by itself. You just subtract the absolute value of x, and there you get y is equal to negative absolute value of x plus 4. The first one takes a little doing, but you can get y squared is equal to negative x squared plus 16 by just subtracting x squared. And then take the square root like we've been doing. So y is the positive square root of negative x squared plus 16. And y is the negative square root of negative x squared plus 16. And we would end up graphing, 1, 2, and then this is the third one. Okay. So I'm going to graph those and see what's happening here. I know through just years of experience that x squared plus y squared equals 16 is a circle. And I know the absolute value graph, I think we did that this semester, but we did last semester with 100, is that V shape. Okay, so I've got a circle and then a V shape happening out of that. So I should see something, graphically. So y equals, clear out this mumbo jumbo. I'll remind you how to get absolute value with your calculator, that function anyway. So we got the square root of negative x squared plus 16, and then the negative square root of negative x squared plus 16. And now let's graph the absolute value. To get absolute value, one of the ways is to hit math and then go over to the number. And the first option, ABS, is absolute value. Okay, so I need the negative absolute value, math, number, ABS of x. And then it's what, plus 4? Plus 4. And I'm just going to graph those. I've got it zoomed in still, so I'm going to have to zoom 6 it here to get it back to the normal window. Zoom 6. So there's our circle because of the way I've got the thing set up. Get a nice, ugly little thing going on there. But how many places is that crossing? 1, getting up here, right? 3, right? 1, 2, 3. Do we even have to trace to find those? They're pretty clear where they're at, right? So there's 1, 2, 3, 4. So 0, 4. And then 1, 2, 3. Negative 4, 0. 1, 2, 3. Positive 4, 0. Those that one's easy to see. We don't even have to trace to get it. We can see where their crossings are nice. What they're called? They're called lattice points in math when they're not decimal. The points are all nice integer values. It's called a lattice. But, very easy to visualize there. Algebraically, not the funnest one to solve. It can be done just by, I would use substitution is what I would end up doing with that. Substitute. I would probably solve for x in the second equation and plug it back into the first equation. But then that gives me a big quadratic to solve twice. But I still get those same 3 ordered pairs if you did it that way. I think graphically is one of the best ways to solve nonlinear systems because algebraically it's hard if you don't know what all the graphs are, and we haven't had experience with all of the circles and all the different graph equations of hyperbolas and all that thing. You don't know how many places it's going to cross. So you don't know if you found all the answers or not. But if you can graph them, get y by itself, type in the equations in here and graph it, you can literally see the places that they're crossing. And that's what I think the advantage to solving graphically in nonlinear systems is. Linear systems, algebraically, is better because you get exact answers instead of kind of eyeballing it. Is that 1.2 or is that 1.3? That's hard to tell. But with nonlinear systems, I think it's better to solve graphically because of that the lack of great methods. Like linear systems, you got matrices, you got substitution and elimination. Doesn't really always work that great with nonlinear systems. So graphically is going to be your best bet for nonlinear systems. So that's what I'm going to kind of ask you to do. All right. Let's look at the last thing for Math 110. Dun, dun, dun. Linear programming. Okay. Linear programming is where you're given a graph. That graph has some sort of polygon drawn on it. And I'm just going to sketch one here. It's probably not going to be perfect graphically, but it's going to be close. Okay. Just eyeballing things here. And I'm going to give you the ordered pairs. On Canvas quiz, on test next week. Oops, put the wrong order pair there. That's 11-7, not 7-5. I'm going to give you that graph with polygon. That polygon is actually found from a set of inequalities that have been graphed. And the overlapping area of the shading is inside of that polygon. That's where that polygon's coming from. I'm not going to ask you to read a word problem and come up with the inequalities and then create that polygon. I think that's asking a little too much for a Math 110 class. And they have never asked that on a final exam to give you a word problem and extrapolate that polygon from it and then do something with it. 2-hour exam, problem like that would take 10 minutes probably to do because you got to pull out the inequalities, then you got to graph them, then you got to find the intersections where they're crossing at, and then you got to use it to do what's the main result of a linear programming problem is this objective function. The objective function or equation, whatever you want to call it, they're going to give you this. They're going to give you z is equal to 2x plus 5y. Who knows what numbers they'll put there, but it'll be x and y. Now, what do we know about these ordered pairs? What are they? They're x and y, right? So on the objective function, the idea is that you're maximizing or minimizing this objective function. If you're maximizing it, what are you looking for? Biggest number, smallest number. Biggest number. So if we're going to maximize this, we're going to plug in every ordered pair that's a corner of the polygon. And the biggest answer for the objective function is the maximum. It occurs at that ordered pair. The smallest number is the minimum, and it occurs at that certain ordered pair. So you're going to get this graph, you're going to get this objective function, and you're going to either maximize it or minimize it according to what they ask. They're either going to ask you to maximize it or minimize it. Really, that's all there is that we're asking you to do about linear programming. There's a ton of other stuff that goes with linear programming, but in the scope of this course, I don't think it's anything you need to overly concern yourself with. So here's the ordered pair, 310. The objective function with that plugged in, 2 times 3 plus 5 times 10. That'd be 6 plus 50, 56. And then I do the next order pair. It doesn't matter what order you go in. I'm just going to go this order. 7, 5, 2 times 7, 5 times 5. That's 14 plus 25. Should be 39. 11, 7. 2 times 11 plus 5 times 7. 22 plus 35. 57. And then the last ordered pair was 5, 13. 2 times 5, 5 times 13. So that's 65 plus 10, 75. From that information, if they ask us to maximize it, we know that there's a maximum of 75 at 513. We know that right there, biggest value, that's a maximum. Minimum, what's the lowest number? 39. What's the order pair it occurred at? 75. So those are the things that you're going to have to do with linear programming. Again, I'm not going to give you a word problem and expect you to pull out the inequalities that make that polygon. That's a tough skill that takes a good bit of practice and experience doing. Guided practice, guided experience doing in order to. I think getting that polygon and maximizing and minimizing it meets the standard that we're trying to get in Math 110. Okay. Things to know this week. What's going to be on Canvas? You got a quiz over these last 2 sections. Short quiz. It's not got very many questions on it. Okay. And then things you're going to see on Canvas. One will be a review for your Chapter 5 test. Things we covered last week, things we covered tonight will be on that test for next week. Next week, we will come in and do a couple of quick labs over what we just talked about tonight, and then the Chapter 5 exam. You will also be getting, through Canvas, a practice final exam for Math 110 with an answer key so that you can start working on that. And the lab that goes with that practice final, it's actually like a half of a final. It's 26 questions, I believe, and an answer key with that. I'm gonna put that out there through Canvas instead of putting a paper copy in your hand. You can print as many copies as you want to. My suggestion is that as you're working to practice up for this final, print you a blank copy, take it work through it the first time, like on Tuesday after you take the test Monday night. Come back on Tuesday and say, okay, I'm gonna take that practice final. I'm gonna take it like a test, and see how you do. You've got the answer key. Go back and grade it. See which ones you missed. Go to your notes and try to figure out what I'm supposed to do on those. And then print you a fresh blank copy a couple of days later. Take that and see if you do better out of that. Okay. And that'll help you get ready for the final exam. Obviously, you can email me questions off of those practice finals that are going to be out there on Canvas, off of these quizzes, out of that stuff. You can email me. I'll get back to you. Try to help you get ready for it. Our final exam will be April the 30th, that Monday evening, 6:15 to 8:15. 2-hour time limit. Expect it to take you the full time. For that, it's 50 questions, multiple choice. Covers everything from 110. And they did not send me a practice final last week. I think I told you guys last week they usually do. They haven't sent it yet. I'm assuming they'll send it this week. As soon as they send me one official one from there, I'll send it to you too. But I'm gonna send you this week a previous final that's actually been given, so that you got something to go by. I think that's better. The half lab, the half test on the lab is actually okay, but I think the full one is better. How that? So that's what to expect this week. Email me if you got questions, and I'll try to get everything graded. And then that way, after you take your Chapter 5 tests, I can email you, each of you during the week there, and tell you what your grade is going into the final. This is what you have before the final. Okay. You are